problem number 2? Yeah.
Number 5.
Number 5, on, this is on the
It's on
previous
page, yeah, 382.
382.
What page is that?
382, number
382.
five.
Thank you.
382, yeah. Does that sound right? It's, Katie earns a commission,
Yes.
14% on all merchandise that she sells over $200. So, 14% commission on everything over, merchandise over $200. Okay, what is her commission if she sells a total of $425? So the formula for commission is what? The amount of commission
Is the commission rate times the total sales.
commission rate times the
Total sales.
total sales. Okay, and so what do we have here? She sells a total of $425, right?
If she sells that.
Yeah, if she sells that amount.
Right.
So as far as the commission is concerned, how much is she going to get a commission on?
25.
No, it says she earns a commission of 14% on all merchandise that she sells over $200. So she is only going to get a commission on how much? She sold 425 total. So she's going to get a commission on 225, right? Okay, so the total sales here as far as the commission is concerned is going to be the 225, okay? And the commission rate is going to be 14%. That has to go in as a decimal, right? And so the amount of commission that she got is going to be the product of those two, and what does that turn out to be? Point 0.14 times 225 is equal to, is going to be $31.50.
31.
Okay, does that sound right?
Yeah.
All right, so now, what is her commission if she sells that? Well, then, this is her commission, right?
Right.
This is what they're looking for. $31.50 is her commission. Does that
was that?
answer your question?
Yes.
Which one?
What number was that?
This was number 5. On page 382. Come on, you silly pen, that's right. Page 382, number 5. Any others on yesterday's? Yes.
37.
37? Okay. A paper shredder with markdown, is that the one?
Yeah.
$79 to $59. Okay, so, is everyone okay with this one? Can I erase it and use the other one? Okay, so if we have a, so 37 paper shredder with markdown from, it was from $79 to $59. That means that the discount was $20, right? Now, what is the percent decrease in price? So how did we, what was the formula for the percent decrease? If we go back over there and look at those formulas, the percent increase was amount of the increase over the original amount times 100%, the percent decrease. So our formula, the percent of the is equal to the amount of the decrease divided by the original amount and then we have to turn that into a percent by multiplying it by 100%. So what do we have there in 37? What is the percent decrease in price? And the percent decrease, the amount of the decrease we already figured out is what? Is $20. So we've got $20 divided by the original amount, and the original amount is $79. So we have to take that, multiply it by 100%, and that should give us our percent decrease. And we can, if we wanted to, if you have a formula, then it's not critical to put it down as assigning the variable, but if you wanted, instead of writing this percent decrease, if you wanted to call that X, then you can just put that in there, and you know what that X was standing for, right? But, so all we have to do is crunch these numbers and see what it comes out to be. So if we take those and work them out, anybody have it already worked out? What does that percent decrease turn out to be?
25.3.
25.3.
25.3? And that has a percent sign, right? Because here you're going to get 0.253 here when you divide that, and then you have to multiply it by 100% to put it into percent, right? Because that's a decimal, and then if that's the number, then that's all done.
And the reason for the 0.3 is they asked you to round it to the nearest tenth.
Oh, okay, because, yes, it says here, round to the nearest tenth of a percent. So when you take that number, 20 divided by 29, or 20 divided by 79, is equal to 0.253164, blah, blah, blah. And then this is approximately equal to this, rounded to the nearest tenth of a percent. And everybody knows how you round it off to any one of those decimal places, right? You look at the next one to the right, and if it's 5 or bigger, then you bump it up by 1. If it's less than that, you just drop everything to the right. Okay? Everyone okay with that? So whoever asked that question, does that answer the question? All right. Any others on that before we talk about head on down the road from where we left off for simple interest yesterday?
35.
35. And this is going to be the last one. So let's, Julie bought a new water efficient toilet for her house, okay? Her old toilet used 5 gallons of water per flush. The new toilet uses only 1.6 gallons of water per flush. What is the percent decrease in water per flush? Well, we're going to use the same formula, right? And what are the numbers that are going to go in there? The amount of decrease is how much? Went from 5 gallons to 1.6 gallons, so the amount of the decrease is how much?
3.4.
So it's going to be 3.4 is the amount of decrease. The original amount was 5 gallons. So we're going to have to multiply that by 100%, and that will give us, this will be the percent decrease. Okay? So if we divide 3.4 by 5, what do you get? 6 point,
You divide that as 0.68.
0.68. Okay, if that's the number that comes out, then you multiply it by 100%, which just does what to the decimal point? It moves it over 2 places, so it looks like 6.8% is the percent decrease.
What number was
So
that?
it is 0.3568.
35.
68.
Oh, 0 point, you're right, okay. So because it would go in here 0.68, and then if that's the case, then it's 68%, okay? I heard you incorrectly. So it's just moving it over 2 decimal places, which if the decimal point is there, which it is, then you get 0.68, and 6.68 times 100% moves the decimal point over here, and it's 68% or 68.0%. Okay? All right. So then it's a matter of plugging it into whichever formula, and if Dr. Little lets you use the formula sheet, then all you have to do is know what number to plug in where, and then use your calculator, right? So it's just writing out the numbers. All right, so let's move on and talk about simple and compound interest. And I put a couple things on the board. What we talked about yesterday was the simple interest formula, which is over here. The simple interest is the principal times the rate times the time, which gives you a formula of I stands for interest, PRT is principal times rate times time. And the total amount in the account at any time is, you have to have the principal in there, which is what you put in to start with, plus the interest. If you're getting interest on some amount of money in the bank or the savings and loan or whatever, then you want that money that you gave them to start with plus the interest. You don't just want the interest, right? And then, so you have 2 different formulas there. You figure out the interest first, and then you add the interest to the principal to get the total amount. And so we talked about that yesterday, and this is the homework assignment for 6.7, just like on the other ones. And then just as a concept connection here to make sure that you understand the pieces of the puzzle there, to find the interest earned on $6,000 at 5.5% for 78 months, I changed it a little bit from what was in the book, just to make sure that we understood both of the pieces there. So what number is used for R in the simple interest formula? Now this is no different than the value for the rate on the other formulas that we had. What are we going to put in there for that R? Are we going to put in there 5.5%? No, because we don't know how to multiply 5.5%. So we're going to turn it into a decimal, right? And if we turn that into a decimal, we're going to do what?
Is 0.05, right?
It moves it over 2 places to the left, so it's 0.055 is what would go in there for the R, okay? Because you're taking this percent sign and you're replacing it with a 1/100, which moves it 2 places to the left. Now, what number is going in there for T in the simple interest formula? Is that 78 going to go in there? No, because that specifically says T is the time in years. So how many months in a year? There's usually 12, right? So if we divide this by 12, what do you get?
6.5.
6.5. So this would be 6.5 is what goes in there for the years. So that's just to make sure that you recognize that if you have months or if you have anything other than years, you have to convert it into years. Okay? Okay, we're good to go. So let's take an example here, and I want to turn one person's test back to her before I forget. In fact, your test is up here. If you want to stop off later and pick it up, or after class, that'd be fine. All right, so let's take this skill practice problem just to exercise that form. Yes.
I have a question. Can you tell me again, for B?
B,
Yeah, for B,
Mhm.
6.5.
6.5.
So I'm sorry, so 0.055, you divide it by?
This one?
Yeah.
No, we don't go from here to here. This is the number for R. This is the number for T.
Yeah, but how'd you get 6.5?
How'd you get T? Okay. Well, this is the time that's given, right? 78 months. How many months are there in a year?
12.
12. So if we take that 78 and divide it by 12, in other words, group them in 12 months is 1 year, another 12 months is a second year. If we do that division, then how many are we going to get? Well, 6 times 12 is 72, right? So if we put a thing here, so that we have a 72.
Oh, I got it. Okay.
You subtract, and 6.5.
Thank
Okay.
you for explaining that.
All right? Yes.
Well, each year, it depends, like, not all years have exactly 12 months, like some, some months have.
Well, I don't think that's true. If you look at January through December, there are 12 months. Sometimes there's a day less in one of the months. But for this formula, we're going to go with 12 months in a year. Because
Okay, I got it. Okay.
Every year has 12 months. You're right. There can be a difference of 165 or 164 days, but we're not talking about days, we're talking about months.
Well, if you want like 79 months, you start getting a repeater
Right,
eventually.
yeah.
So what do you do in the case if somebody wanted like 79 months? Just round it off then?
You'd have to round it off. They'd have to tell you how to round it off.
Right,
Okay?
okay.
That's why I picked 7.
Yeah.
Okay. Yeah. And I think most of the problems that you run into, you will run into where it'll come out to be a terminating decimal, not a repeating decimal.
Yeah.
Okay? But you would have to round it off if you got a repeater. Okay, and this is just to clue you into the fact, make sure that time is in terms of years. Okay, so here, if Morris takes out a loan for $10,000 and he pays simple interest at 7%, that's an annual rate. If you notice over there, that is an annual interest rate that'll be assumed in here at 7% for 66 months. First of all, the thing they want to do is to convert 66 months into years, and what would that be? 66 months is how many years?
5.5.
5.5.
3
Because
years,
5 times 12 is 60, and then you have 6 months, which is this other 0.5. Or take the 66, just like we did there, and divide it by 12, and you'll get 5.5. Okay? So that is the T, all right? Now, how much money does he pay in interest? We're going to have to use that formula, right? We're going to have I is equal to PRT, and the principal is the $10,000, right? $10,000. Then the interest is going to get, that annual interest rate is going to go in there as decimal, as 0.07, and then the years are going there at 5.5. And it's a matter of crunching those numbers, and how much, what does that come out to be if you work those numbers?
3,850.
3,850?
Yes.
Anybody disagree with that? Okay, so if that's the interest, then how much total money must he repay to pay off the loan?
1,300, 850.
Right, because the total amount is equal to the principal. You have to pay the bank is going to want their principal back, plus they're going to want this interest, and that's the $10,000 plus the $3,850, and that is $13,850 is the total amount that he's gonna have to pay before they're going to figure that complete, right? We're going okay with that? So it's just a matter of exercising that formula, but you have to put in the decimal form of the interest, and you have to put in the time in years. Okay, now, when you're working these problems, particularly on a test or whatever, you know, you can at least do a sanity check on these pretty easily, right? Because if you come down here and how much total money must he repay to pay off the loan, if you come up with a value that's less than $10,000, what are the chances of you being right? Not very high, right? Because you're not going to get out of there without paying more than $10,000, because the bank has to make their cut, and it's got to be bigger than that. And you'd be amazed at some of the values that come back on tests for these. I mean, they're way out of the realm of reality. But so they have to be reasonable, is what it amounts to. Okay, now let's get to we want to talk about compound interest. And we're going to do that by taking a look at example 3 that compares simple interest and compound interest. We're going to start with $1,000 because that's a nice round number that the figures are pretty straightforward. Suppose that you have $1,000 and you invest it at 8% for 3 years. And the first thing we want to do is to compute the total amount in the account after 3 years using simple interest. So it's going to be the same kind of problem we have over there. We have the principal is $1,000, the interest rate is 8% annual interest, and the time is 3 years. So the PRT is 1,000 times 0.08, which is the decimal form of that, and the 3 for the years. And if you multiply those numbers, I think you get $240, okay? Now, so the amount in the account at the end of that 3-year period is the principal plus the interest, which is 1,000 plus 240, which is $1,240. Everyone on board with that? And if we wanted it for 4 years, 5 years, the only thing that would change here is the 4. This would, for 4 years, this would change to a 4. For 5 years, it would change to a 5, and so forth. So what that says is that you're getting this amount of interest each of those 3 years, right? So you're getting $80 each year, so at the end of 3 years, you would have $240 in interest, all right? Now, if we come over and compute the interest compounded annually over that same 3-year period, they have this little chart in there, and I think this is good to show you what happens with this compound interest and why they compound it, why they call it compound interest. And it will be based on the basic calculation is going to be that interest each year is going to still be that PRT, right? But what's going to change is that you're going to get interest on your interest. And let me show you what that means. So for the first year, the interest is going to be the same as it was there, right? Because you've got $1,000 at 8% times 1 year is $80. The amount that you have in the account at the end of that first year is $1,080. Now, if you are talking about simple interest and compounded annually, interest compounded annually, how does the interest compare at the end of the first year?
It's the same as the first year.
It's exactly the same, okay? Then it changes, okay? Because when you talk about compound interest, you take the amount in the account, which includes the interest, and that goes in as your principal for the next year, okay? That's what is meant by compounding. So the I equal PRT is still the same formula. The only thing that has changed is instead of the $1,000 in there, it's now $1,080. And for the second year, you're gonna have that $1,080 times the same annual rate times 1 year. So instead of $80 interest for the first year, the second year, you're gonna get $86.40. It's more interest because this is higher, all right? It's compounded, that's what compounding means. And then the total amount in the account at the end of the second year is going to be what you started with over here, the P plus the interest, which is now $1,166.40. Questions? Okay, does that make sense? So this is compared to the 1080 that it was there. If you talked about this simple interest at the end of the second year would just be 80 plus 80, which is 160, right? So it's higher with the compound interest. And then the process continues. You take that amount that's in the account at the end of the second year, that becomes your principal over here for the third year, and then you can see that this amount of interest that you're earning each one of those years is getting a little bigger, right? And if you have compound interest and you do it over 20 years, there will be a significant difference at the end of that time period, right? But this is what compound interest, where you're compounding it annually, this is how it's working. So it really comes back to simple interest on each one of those years. What's changing is this principle that you're taking the interest on, or the interest is based on. Everyone see what's happening there? So it's not, it's not nuclear physics or black magic, it's just crunching some numbers. But that's the key part here, is that principle is changing from year to year. And it's changing by adding on the amount of interest at the end of that compounding period. So it gets bigger and bigger as you go along. So the total amount in the account at the end of 3 years here, we see is $1,259.71. So the difference between this and this, you can figure out what the difference is for the due to the compounding. All right. Now, as they point out in the book, and I think you brought this up yesterday, this is compounded annually to show you how it works. Now, if you go down and talk to your local banker or the savings and loan people, if they're trying to get you to put your money into their savings and loan, they're going to say, well, instead of compounding it annually, we can do a lot better than that. We will compound it semi-annually. And the next person might say, we can do better than that. We'll do it quarterly, and or monthly, or in fact, on some of them, it's down to daily or down to even continuously, which sounds like you should get an infinite amount of interest, right? But it doesn't work that way. But there is a formula for that, and that's why Dr. Little said it's a good idea to get a scientific calculator, because you would get very tired of doing this if you wanted to figure out how much was the compound interest at the end of 30 years, if it was compounded annually or monthly or whatever, at a certain rate. Okay, the calculations, you can do it, but it's going to take you a while. And before the days of the calculator and computers, you see the old movies where the guy is sitting in the back room with the green eye shades doing things. That's what they're doing. Okay, they're crunching through those numbers, and then they develop big tables for them. But they did it by hand, basically. All right. But now it's a matter of pushing a button and you get the answer. And so that's where the formula comes from for the if we take a look over there on the bottom of the page, there's a formula that says A is equal to T multiplied by 1 plus R over N with an exponent of N multiplied by T. This is the formula for computing the amount in an account. That would be where we should be able to go right to this number after a certain amount of time. And these things here are going to be, the principal is still P. And what do these other numbers mean? Well, R is still the annual interest rate. The T is still the time in years, so those haven't changed. The new player on the block is N is equal to the number of compounding periods per year. Okay? So this formula, we should be able to take this and take our problem over here and put the numbers into the calculator and see what it comes out to be. Now, this N is used twice. It's 1 plus R over N, and then this is an exponent on this quantity. So you'll need to figure out what this is first, and then raise it to this power. So let's do this same problem using this formula. Okay, and if you are interested, you can probably convince yourself that this works, because as you go through this, what's changing are this, at the end of the first year, it's just 1 plus the rate, which is the 0.08, 1.08 to the first power, which is just the principal times 1.08. So that'll give you that same thing. And if you do it for 2 years, then you'll get the second one, and so forth. But let's not worry about that. Let's just worry about having the formula and then use it, right? So let's take this exact problem and put the numbers in there and see what comes out. Okay? And if we do that, what is the principal? The A. Hey, let's knock off the noise, okay? If you think it's out in left field, then keep it to yourself, okay? Because people are trying to understand what's going on, and so just keep it to yourself. If you think it's way out of bounds, then that's your opinion. Whatever other people, it is not difficult. And do you have a calculator?
Yeah,
Do you bring it?
yeah.
Okay, so it might be a good idea to get it out, and we'll run through these numbers and see what we get. So here we've got the A is equal to, what's the principal? Well, we've already used that over there, right? The principal is the 1,000. And then we have 1 plus, now the rate is the annual interest rate. That's going to go in there as the 0.08, right? So this is 0.08 divided by the N, which is, now this is the number of compounding periods per year. The number of compounding periods per year. Okay? There are 3 years, but how many times are we compounding this per year? 1, right? So this is going to be this over 1. And the exponent there is going to be 1 times the time. Now that t is equal to the 3, okay? So this, with any luck at all, should give us that same number, right? Do we have the pieces in there correctly? The compounding periods, remember those are per year, all right? Okay, so now, and this A, whereas here we had to add the principal to the interest each year, that's built into this formula. So the number that comes out of this calculation should compare very closely with what we have over there. So if you have your calculator, go ahead and pull it out, and let's put these numbers in there and see if we get it. Okay, so take out your calculator since you have it, and let's put them in there and see what we get. And if you don't have a scientific calculator, then you're going to have to resort to building up this table. So you probably want to get one, because I would suspect that Dr. Little is going to give you a problem where you're going to be able to exercise this formula. So here, if we have 1,000 for our number there, this is going to be 1.08, and that's going to be raised to the third power, right? So if we do this, if we follow the order of operations, we can do this. And if we do it that way, we've got 1,000 multiplied. If you take 1.08 and raise it to the third power, your calculator should have an exponential.
You gotta do that first, raise the 1.08 to the third power
Right.
before you times it by the power.
Yes, you don't want to multiply this times this and then raise it to the third power, because you'll get a humongous number. And you do your exponent first. What is 1.08 cubed? Let's see, we got 1.08, and now there's an exponential on there. So if you put that in, it's like an x to the y button. If you do that one and you put in a 3, then what do you get out? 1.259712, right? Everybody get that number?
No.
No?
I got 1.36.
Does your calculator have like a?
X to the Y.
Yeah.
I
So
got the 973.
1.08.
X to the Y.
Yeah, so that's the x, and then the y is the 3. So if you put that in there and then hit a 3, then,
Equal. Oh, yeah,
okay, it should give you this number, right?
Yeah.
Everybody get that number? So then, if we multiply that by 1,000, what do we get? A is equal to 1259, because we're moving it over 3 places, 7, and it's, the decimal point is 1, 2, 3, and it's going to be 7, 1, 2. So that A is equal to 1259.71, rounded off to the nearest penny. All right? So which is exactly what we got over here in these calculations by hand. All right? And it's not, it's not way out of reason to do it this way if we're talking about annual interest and do it for a couple of years. But if we're talking about monthly interest for 25 years, you're going to lose not only interest in the problem before you get finished, but you're going to lose your train of thought because it's going to take you a while, right? So that's why Dr. Little said it's good to have, a scientific calculator. But if you don't have a scientific calculator, you don't have to have one. If you understand the concept behind it and understand how to use it, then you can always borrow somebody's calculator or whatever to figure it out. But the key thing is that you understand the difference between compound interest and annual or simple interest. And the fact is that at the end of each of those compounding periods, you're going to fold that interest back in. So if you're compounding it on a monthly basis, it would be a chart that looks just like this, but you would do it how many times for the first year? 12 times. Every month you would do it month 1, month 2, month 3, month 4, month 5, up to 12. And you'll get the same answer, within, rounding that you got if you put it into your calculator. So you could do a problem that is very complex if you had to do it that way very easily by putting them in this way. Okay? So did everyone get this number to come out? This one first, the 1.08 to the third power there? And what would the only difference be here if we were talking about this compounded, instead of annually, if we were talking about it quarterly, say? That means we would compound it 4 times a year, right? So what's the only thing that's gonna change in this formula if we do that? Not the 3.
No, the one would change to a 4.
This would, the n would change to a 4. So you'd have a 4 down here, and you'd have a 4 up here. So that exponent that you're raising this to is going to be 12, right? So, but it would be the same game. So once you get these numbers defined, then it's very easy. You just put them in there and hit the button, and out it pops, okay? So you can see where this, you'll get your answer in a matter of, however fast you put it in there. But don't change the 3, because the 3 is the time in years, okay? This is the compounding period, so this is what's going to change if you go from annual to semi-annual to quarterly to monthly. That n is going to change, all right? That's the only thing that's going to change, and of course this exponent will change and this will change, which means that this calculation will be different and this one will be different, because that exponent will be a lot larger. Any question on how to use the formula? It's just a matter of figuring out what those numbers are and plugging them in there and using them. Let's see if there's a problem here that we can go through. Let's do the next skill practice problem there, which is very similar to the one that we had there, which is probably a good way to just check and let's everybody do the same problem and see what you come out with for an answer. So now we've got $2,000 invested at 5% interest, compounded annually. So it's going to be the same game we had there for 3 years. So it's going to be very similar to what we had there. And we want to find the total amount after 3 years and see what we get. So what's the difference going to be between what we have here and what we have here? The only thing that is changing is the interest rate, right? So let's go ahead and figure this out. So and remember that the A here, this is the total amount in the account at the end of the 3rd year, if we're talking about 3 years. So it's going to be $2,000, because we're investing $2,000 rather than $1,000, so that's our principal. Then we're going to have 1 plus the rate, which goes in decimal, 0.05, over, and we have N, which is annual, once a year, and then over here, we're going to have N times T, so it's going to be 1 times 3 again. So it's going to be very similar to what we had over there. We're going to have 2,000, 1 plus, now it's going to be 0.05 raised to the 3rd power. So what do you get when you put those numbers in your calculator? Does everybody agree that this is what we put the things in the formula correctly? Everyone see why these numbers are what they are?
Where's the 1.3 come from?
This is not 1.3, it's 1 times 3.
Oh, 1 times 3.
Right. You just can't read my writing. No, this is 1 multiplied by 3. Okay?
That represents the 3 years.
Yeah, and that's the 3 years and only 1 compounding period per year. Okay? And so then when we take this would be, if we do this calculation, you can do it all at once, but you have to be very careful how you put those parentheses in there and so forth. Let's just do it following the order of operations. So this is going to be 1.05 cubed, so we would do that first and then multiply it by that. So if you cube 1.05, what are you going to get? That's that X to the Y button, and Y to the X, so it's 1.05, and then put in a 3, and hit the equal sign, or whatever you have there. So this is going to be 2,000 multiplied by, what number did you get?
1.157625.
Yep, that's what I got too, 1.157625. Did everyone get this number? Okay, so then what we have to do, then we have to multiply it by the 2,000, and then we have times 2,000 is equal to 23, 15, 25?
Yeah.
Everyone get that? So it's just a matter of putting it into your handy dandy calculator and letting it do its thing. Now, if we wanted to change this, we could just talk our way through it. If we wanted to change this to compounded monthly, what would that be? If we change this to
Yeah.
monthly,
And 12.
N equals 12.
N is going to be 12, so here, so this over here for monthly would be, the amount would be, we still have the $2,000. For that, we have 1 plus 0.05 over 12, right?
Okay.
And then we're going to have N, which is 12 multiplied by 3.